In this lesson, you'll learn how to create class and instance methods and share those using inheritance. While you can use the Ruby-provided object class for ad hoc objects, it's frequently more useful to define your own class so you can create multiple objects that all have shared behavior and patterns of data. For example, you could define a ticket class that is built so that every individual ticket instance has the same ticket-related methods. Classes give us the ability to organize data and behavior into similar blueprints for objects. In order to define a class, you use the class keyword. Let's stick with the ticket theme and create a ticket class that has one simple method. Now that ticket has been defined, you can create a new ticket object using new. New is a special class method called a constructor that's made available on every new class as a way of creating a new instance of that class. Running this code will return behavior will be added later. This doesn't seem like much, but we've written and executed our first instance method. To be clear, an instance method is a method that is defined inside a class so that all instances of the class can use the method. Methods that are defined for one particular object are called singleton methods. When we created our first general ticket object, we hard-coded the ticket state. For instance, we made the price method return a specific hard-coded dollar amount. Now that we're using classes, we need each instance to have its own associated data, or state. Ruby objects come with their own storage and retrieval mechanisms for state, instance variables. These are the rules for instance variables. Names always start with a single @ sign. That way you can identify an instance variable at a glance. Instance variables can only be accessed by the object to which they belong. An instance variable initialized within one instance method can be used by any other instance method within the same class. A class can have a special method called initialize. This method is executed every time a new class instance is created. We can use this initialize method to set an object's default state. Notice here that we not only defined our initialize method, but we also created get methods in order to access our instance variables. You can see in this code how these get methods are used to access the instance variables. What about when we need to set or change an object's state at some point in our program? Let's define our class again, but add a price instance variable and a setter for price. Notice that the setter method is defined as the variable's name followed by an equal sign. The setter method is also defined with a name parameter. The parameter you pass into the setter method will be the new value that is assigned to the variable. If you want to set or change that variable, you call that method like this. The Ruby interpreter allows us to write this code in an even simpler way. When the interpreter sees this code, it will ignore the space before and after the equal sign. You can also omit the parentheses as they're optional for method arguments when calling a method. Ruby lets objects have singleton methods, and classes are objects, so we can write this and define a singleton method for ticket. Instances of the ticket class will not have access to that method. The new method is a great example of when and why class methods can be useful. The job of spawning a new object logically belongs to the class. It doesn't make sense for individual instances of ticket to be able to spawn each other. Class methods are often utility methods or helper methods. Think of working with temperatures in your code. You might want to be able to use a temperature Celsius to Fahrenheit class method to convert a Celsius temperature to a Fahrenheit one. It might make more sense for that method to live on the general temperature class and not need to live on every instance of a temperature in your code. Classes you define and the instances of those classes that you create are both objects. A class object like ticket has its own methods, state, and identity in memory. These aren't shared with the instances themselves. The definitions within your class provide a blueprint for how instances of that class should behave and what data they should contain. Calling a method on ticket itself is different than calling a method on an instance of ticket, in the same way that calling a method on two different instances of a string will yield different results. Let's create a new class called beverage, define its initialize method, and create getters and setters for each instance variable. Now let's create a few instances of our beverage class. Next, we'll make sure the getters and setters are working. This next part you'll do on your own. Think of your own object that you'd like to represent in code. Then create a class to represent that object with an initialize method and getters and setters for all of the attributes. Create multiple instances of your newly defined class. Interact with each of your instances by getting and setting each of the attributes.